In our everyday life, we come across a number of situations where we need to calculate how many ways there are to perform an activity. This falls under the branch of mathematics called combinatorics. Let's look at an example. There are two cities, City A and City B. To travel from City A to City B, there are 3 buses and 2 trains available. In all, how many ways are there to travel from City A to City B? Now let's take another situation. There are 3 cities, A, B and C. There are 2 routes from City A to City B and there are 3 routes from City B to City C. In all, how many routes are there to travel from City A to City C? Let's take the first case. There are 3 buses and 2 trains available to travel from City A to City B. Therefore, there are 3 plus 2, that is 5 ways to travel from City A to City B. From this scenario, we can conclude that a task is completed when one of the subtasks among the collection of disjoint subtasks is completed. So, the total number of ways is obtained by adding the subtasks. We can formulate this observation as the addition rule. When the task is completed by performing one of the 2 or more disjoint and mutually exclusive subtasks, which can be performed in m and n ways respectively, then the total number of ways of performing the task will be given by m plus n, the sum of the ways of performing the individual tasks. The addition rule can be extended to any number of tasks. That is, if there are n1, n2, n3 and so on up to nk mutually exclusive ways to perform the subtasks available to perform a task, then the task can be performed in n1 plus n2 plus n3 and so on to plus nk ways. Let's now move to a second case. To travel from City A to City C, one has to travel first from City A to City B and then to City C. One can choose the route A1 from City A to B and then any of the 3 routes B1, B2 and B3 to travel from City B to City C. Similarly, one can choose the route A2 from City A to City B and then any of the 3 routes B1, B2 and B3 from City B to City C. Here, the journey will be completed only if both the subtasks are completed. Therefore, there are 6 ways in all to travel from City A to City C. We can also check this using a table as shown. When there are m ways to perform a task and there are n ways to perform another task, the total number of ways to perform both the tasks, one followed by the other, is equal to m times n. Notice that the order of the tasks is immaterial when finding the total number of ways. So we can conclude that if a task can be accomplished by performing 2 subtasks which can be done in m and n ways, then the task can be accomplished in mn ways. This principle is known as the fundamental principle of counting or multiplication rule. We can extend this to any number of events or tasks. That is, if there are n1 ways to perform task S1 and n2 ways to perform task S2 and so on to nk ways to perform task Sk, the total number of ways to perform all the tasks together in a particular order is n1 times, n2 times and so on up to times nk. Let's now compare and find out the difference between the addition rule and the fundamental principle of counting. In the addition rule, there are a number of independent jobs and we have to perform one of them to perform the task. So, the total number of ways of completing the task is the sum of the number of ways of completing each sub-job. Whereas in the fundamental principle of counting or multiplication rule, a job is decomposed into a number of sub-jobs which are unconnected to each other, and the job is said to be performed if each sub-job is performed. So, the total number of ways to perform the job is the product of the number of ways of completing each sub-job. Let's take some examples to understand the addition rule and the fundamental principle of counting. A college offers 5 courses in the morning and 3 courses in the evening. In how many ways can a student select a course? The student can choose any of the courses offered in the evening or in the morning. Therefore, there are 5 plus 3 equals 8 ways in total to select a course. Let's look at another case. There are 5 floors in a building and each floor has 20 rooms. In how many ways can one select a room in this building? In order to select the room in the building, we have to select first the floor and then any room on the selected floor. Out of the 5 floors, one can select one in 5 ways, and then one can select a room on the selected floor in 20 ways. Therefore, in total, there are 5 times 20 equals 100 ways to choose a room in the building. Let's look at this case. There are 3 teams in a company having 4, 5 and 6 members respectively. 2 members from the same team are to be selected as president and vice president. In how many ways can this selection be made? The number of ways of selecting a president and vice president from team 1 is equal to 4 times 3. Similarly, the number of ways of selecting a president and a vice president from team 2 is equal to 5 times 4. The number of ways of selecting a president and a vice president from team 3 is equal to 6 times 5. Therefore, the total number of ways of selecting the president and vice president is given by 4 times 3 plus 5 times 4 plus 6 times 5, which is equal to 62.